We're going to talk about factoring algebraic expressions. Now, whenever you find yourself having trouble with math, it's helpful to remember that mathematics has its own language with both words and symbols. Taking a few moments to explore what those words and symbols actually mean can go a very long way towards helping you overcome your difficulties. In that spirit, let's make sure we understand what factoring means and some of the other terms that might be helpful to you when we look at this video are these terms. It would be helpful for you to take a moment and look up those terms and just make sure you understand what the words actually mean. Let's start off with factoring itself. Factoring means reversing multiplication. So you're starting out with the end result of the product and you're going backwards to figure out what you multiplied together to get that product. It's not quite the same as division. Here you see two examples of beginning with the product 12 or the expression x squared minus 16, and then we go backwards and figure out what we multiplied together to get those things. Division, on the other hand, really only gives you one answer called a quotient. All right? The one answer there you can see for the first line is 4, that's the quotient. For the second one, it's x plus 4. But with factoring or reversing multiplication, you have to have a minimum of 2 results, 2 factors. It doesn't make sense to have less than 2 because you can't multiply just one thing. Right? You need at least 2 things to perform the operation of multiplication. That's really important. Also important to remember that you can have more than 2 factors to an expression or to a single number. For example, 12 can also be written as a product of 4 separate factors. And that's important to remember. All right, so the first method that you're usually going to try when it comes to factoring an expression is the greatest common factor method. All right? And those words kind of give you a clue as to what you're looking for. Greatest is going to mean the biggest thing in some sense. Common is going to mean that it shows up in every single term. And of course, a factor is something that you multiply together to get a product. So here's a simple expression. 6x squared minus 18x. What you're going to do to find a greatest common factor and then use it to factor the expression is factor out the GCF, that's short for greatest common factor, first in that order, coefficients first, then variables, and then divide the original expression by the greatest common factor to find your second factor. Remember, when you factor, you have to have at least 2 results, 2 factors. Otherwise, it doesn't make sense. Okay, so let's start with step 1. We're going to factor out the greatest common factor from this expression. There's 2 terms here, the 6x squared and the minus 18x. So we're going to start with coefficients. Remember I said earlier, knowing what the words mean can really help you understand what to do here. So coefficients are numbers that multiply a variable expression or term. So there are the coefficients of the 2 terms in this expression, the 6 and the negative 18. So we're looking for the largest number that divides each of those things evenly, and that would be 6. So the GCF of the coefficients is 6. That's going to become the coefficient of our GCF. You'll see that in just a moment. Now we move on to the variable terms, but remember, they have to be common factors. So a variable has to show up in each of the terms of your expression, or you cannot include it in the GCF. So in this case, we have an x squared in the first term and an x in the second term. So when you go to factor out a common variable factor, you're looking for the largest power that divides all of them evenly, which in effect is really the smallest exponent term of the variable. In this case, it's x to the first. So the GCF of the x variable terms here is x to the first power. So our GCF for the whole original expression is 6x. Right? Now we have to take that GCF and we have to find the second factor. And to do that, we divide the original expression by the GCF. So remember our GCF was 6x. So we divide the original expression by 6x, one term at a time. When you divide the first term by 6x, well, 6 divided by 6 is 1, and x squared divided by x is x. It might be helpful for you to remind yourself of the rules for dividing powers of the same base. You subtract the exponents and you keep the base the same. So the quotient of those first two terms is going to be just x. Now we move on to the second term of the original expression, and we divide that by the GCF. So negative 18 divided by 6 is negative 3, and x divided by x is 1, so we get negative 3 times 1, or just negative 3. Now that's our second factor, but remember, to factor something you have to list at least two results, or it doesn't make sense. To reverse multiplication, you needed at least two things originally to multiply together. So we're going to write the product of the GCF and the second factor together. And there we go. There's your answer, 6x times the second factor of x minus 3. That's essentially the technique. Now, it certainly can get more complicated with fractional exponents, with expressions, but the technique is always the same. You're going to follow those basic steps. So why don't you try a practice example? You can pause the video and see if you can follow the same steps that we just did to come up with a factoring of this expression using the GCF. I'll wait for a moment and then I'll continue. Okay, so the GCF of all three of those terms, if you do the coefficient first, would have been 7. And for all the variable terms, the x's are in each term, and the one with the smallest exponent is x squared. So 7x squared would be the GCF of that original expression. And when you divide each term of the original expression by the GCF, you get your second factor. And then, of course, you write your answer as a product of the GCF and the second factor. You have effectively reversed multiplication. Now, that's the end of this video essentially, although I'm going to put up two challenge questions for you. One of them is when you're factoring with GCF and more than one variable term. You can see I put the solution there. You can try to match that. And the second one is when you're factoring out a common expression. In each of those terms in the bottom example there, the expression 2b plus 3 is common to the first term and the second term, and that actually can factor out as a GCF. So see if you can match those two, and then in the next video we'll move on to the next factoring technique.